Hello everyone. If you saw my last video, I was showing my original spider's leg, or insect leg, or whatever. It's a leg anyway. And I was going to do one out of wood, and I finally have. So here it is. I've got all the servos, all four of them, hidden inside the body of the leg, and then so everything comes out as one piece. And I think this actually looks a lot better than the plastic one. So let's just move that in. Well, I'll move it down here, but it shows all 16. My app shows all 16, so server, well, all 20 servers, but there's only 16 broken out. Let's just bring it down here so you can only see the 4, and then you'll be able to see my my legs. So if we look on top, you can see that server 1 is the one that moves it from side to side, shall I say, or forwards and backwards. Oops. Alright, so let's try and get that so you can see it move that way. Obviously that's one of the servos. I'm controlling it through I2C at the moment. You can see I've got it selected to I2C, and I'm on this address, and we're connected at COM port, and it's going through this Arduino because we're going at because we're going on the I2C. I need the Arduino to control the I2C, and I've also got an LCD on this Arduino, so we can see the results that we send. So like I say, we've got 64 here, down there, and you can see that was leg 0, 64. So if we go up 1, you can see it move. It's now at position 74. And if we use the servo 1, you can see that it's now changed to 1, and it's at 90 degrees like we have here. There's 4 servos inside here. One's for this part. It moves it sort of like that, and then the other's for this part, and that moves it here. This is the joint for that one, and it moves this part, which is this is the joint for this one. So the way it works, this one is moved by this lever that goes all the way across the top and down to a servo. This one is connected by this link here, which is connected to another servo, which moves that, and then this one here is connected to a servo at this point here, which just pushes it out, in and out. So if we look at this one first, we can see that servo 1 moves that in and out. Let's just bring it back to somewhere near 90. And then we can look at this one here, this linkage here, which is this servo underneath there. That link goes to that servo, and that controls this arm here, this part. So that'll be servo number 2, and we can see that. Try and keep it in shot, and that moves that one down. Let's just keep it about there, and that's a nice binder shape. And then the last servo, number servo 4, which is number 3, that's controlled by this servo, which is fastened to that link going back to here, which then is linked to this piece. Then it has a knee joint at the top, and then this piece, and then down to the toe. So if we move the 3, you can see it moving. We just need to move that out a touch. Let's bring that out. because it's done by linkage, you can't have full movement on all the links at every position. But there you can see that moves now. So yeah, that's my spider leg, and obviously what we'll do is get 8 of these, and then I've got some bolt holes at the back where we can I can bolt them all together onto a body. So I hope that you like that, like the shape and the design and the way it works. Oh, and the rotation is done by a servo and a gear. So there's a gear on the end of that servo, and that rotates a crown and pinion sort of type effect. The crown is actually screwed to this piece, and so as the gear rotates around the crown, it moves the whole assembly. So let's just put that out of the way for now. Yes, and so the software I've done for the Arduino for this test, I've used I've made one. I use Visual Studio for doing my Arduino sketches. I use Arduino for uploading to the microcontroller still, but I don't know if people are aware. Like I say, I use Visual Studio Community because it's got a very good intelligence, sort of I forget what you call it now. Ignore this. This has got nothing to do with the Arduino sketch. I'll just when I've done a copy, I will. It'll be like that, and you can just leave that there. But you can see all this red stuff. It's finding issues. This is just a header that I've used to let Visual Studio know where all the Arduino files are, and that way it can do its stuff. But the reason I use Visual Studio is, say I wanted to look at the wire header, all you have to do is right click and go to document, and there's the wire header, and I can look at what's the wire header has. Or say I want to, if I'm doing some stuff where you see the read the read serials here. But say this is somewhere else, it's miles away from that bit of code. I can just right click on that, and then I can do a quick preview, and I can see what see the read serial. It's really simple. Or I could go straight there, even with the print line or whatever. Say I want to know what print line is, I can just pick the definition, and there we are. There's the definition for the print line, and these are all the choices we've got. So it's quite a powerful IDE. It's got a fantastic IntelliSense. It's brilliant. And then obviously, like I say, if I edit this and save that now, if I save it, when I go to this, I'll just show you a demonstration here. You see this, it says include. I'll move that out of the way, say I was going to upload it. So like I say, this is just for my benefit using Visual Studio. So I'll just get that out of the way like that and save it. And then if we can come to here, you can see that it's all ready for upload. It's done the editing. It's moved it up to here where it is. And this, I don't know if anybody's aware that the Arduino IDE has this option for using an external editor. If you want to do this sort of do all your coding in an external editor, all you have to do is go to File, Preferences, and then you've just got this Use External Editor here. Basically, you just tick that. Okay, I mean, you can't edit anything in here while that's on. If you want to edit in the Arduino IDE, then you need to turn it off. But what it does is it checks for any changes of the file and updates it. So I can use everything in here. So if I wanted to see what this file is, just right click, go to, and there we are. So it makes things a lot easier, and that's the reason also I use comments as well. So we've got comments there. So if we go to void set, you see it's got one time run. That's my edit. That's my comment there. So let's say I no, not that one. Where are we? Oh, right. So you see, I've put this comment initialize serial, and it's here for this function. So basically, if I just go and look where I've stuck that. Oh, let me just stick that file back. That's back. There we go. That tidies everything up. So we've got there, and if I just go to the next one, there. So you see where it says initialize serial. It's only down here, but if it was a big sort of coding file, I could just move my mouse over it, and you can see the comment underneath, initialize serial, which is, I'm trying to move my mouse over it, but I can't. But you can see where it says initialize serial. Alright. I wonder if there's another one. Well, there's no. It's only a little tiny sketch, is this, but basically, so ignore this. This is just for my use. So we've got some definitions here. We've got 4 definitions. Debug, right? So you may as well leave that active. What debug does, it sends the information back to where are we? So look, yeah. So on here, all this information, this is what's been sent with debug turned on. So it sends all this information back. Well, it's this bit here basically. The OK is this handshake. When we get an OK, it tells my application that it can now send another command. It won't send another with the handshaking on. It won't send another command until actually it receives an OK. So that's what that is there basically. Has LCD? Well, I hope that's straightforward. Basically, I have oh, what's happened to that? Damn. Excuse me. Some reason my camera reset there for a moment. I'm not going to do this video again. Some's already interrupted. Right, okay, so is that yeah. So yes, I have an LCD attached, and so basically that just I'm on one of these little breakout boards. It has the I2C pins here, and now what I've done is I've made a little bus here so I can stick lots of I2C devices in, and I have one of them is this LCD screen. It has the LCD the I2C adapter on the back, so it displays what we're sending. Yeah, where was I? There we go. Yep. So that's all that is. If you don't have an LCD attached, just comment this out. Just go in front and just go comment it out like that, basically. And then we've got two choices. We can either have this one or we can have this one. So if at the moment on here I'm connected through this cable on the I2C bus. So on the firmware I have this active. If I wanted to talk to these two wires on the I've made a serial, a soft serial on these two pins, because we need to talk through the UART on the Arduino through this USB, so we can't use the UART on the Arduino. We need another UART, which is a soft serial, and that's on these two pins. So if you want to use UART, then you comment that on out like so, and uncomment this one like so, and then you upload it to this. In fact, what we'll do is I'll just move that out of the way. There. Save that. And what we'll do is we'll now change this. Change the software to... oh, hang on, just one moment. I forgot to DC... need to DC, otherwise you can't have two talking on the same thing. So there, so it's now actually set up for UART. And so what we'll do is now we set up for UART. I don't need this one connected anymore. That's my spider's leg. Turn that off. So that's my spider's leg disconnected. That was the power. So I'll just move that out of the way. So now what we have is this. My Arduino is connected to this one. This one, which I have wired up as UART. Let's bring that up to a bit closer. There you go. There. It's on this TX and RX pins now, not on these. So and they're on pins. I've allocated 6 and 7. So don't know if you can see that. But anyway, it's pin 6 and 7 there that I've stuck those onto. So that's it. So we just need to add a bit of power. So I'll just take power off there. Add power to this. That's for the servos. And I'll just grab a servo and stick a servo on there. Oh, and yes, while I'm on it, when we're using UART, it's only a one-to-one thing. That's why we have to put a separate soft UART on here, because I'm using the hard UART through the USB, so we can't use that for talking to this and my USB. We need a separate one, so it comes in on the USB. That goes through the hard UART on the Arduino chip microprocessor, and then it comes out on the soft UART to the microcontroller. So we've got power, we've got servo, got that connected. So bring the software back. We're on UART now, and obviously on UART we need to talk at 9600. Before we were on I2C, whereas I had set the Arduino to talk at 11500, but because we're talking to this on the UART, we cannot. The UART on this device is only at 9600, so I've set the software on the Arduino at 9600 also. So that's what we'll connect. Keep things clear and simple. So is that the right? Yeah, I believe 11 is the right. Well, let's give it a try. and find out. Yeah, that's the right one. So there we go with the UART connection, and you can see this is the feedback that's coming back. Now that's coming back in hex, but what that hex actually is what's written on front of there, which is 2500.003 and 254. When you're talking to UART, you need a header ID and you need a footer ID. The address is 0, and then you have the servo number, which this one is 0, and then you have the position, which is 3, and you can see down here. Oh, hang on, move it into shot. So there we go. So basically we can move that around basically there. So that is UART through the Arduino. So what we'll do next is oh yeah, of course we need handshaking as well, because we're talking through the Arduino as well. What we're going to do next is we're going to we're going to get rid of the Arduino altogether. So we don't actually need an Arduino to be able to talk to this. What we can actually do is we can use a USB. Oh, right, there we go. Is it getting focused? There we go. A USB to serial or transistor logic, UART, whatever you want to call it. You can use one like this. Yeah, so one like that, or there's some even cheaper ones like this. I love this one, basically. This one. This is one that is using the CH340, which is the cheap one on the market. And I've got, like, I can talk to it either 5 volts or 3 volts. I've recently been talking, I've got on 3 volts because I've recently been altering I've got it here, altering the speed on this, because I wanted this set at 9600 Bluetooth module, so that's why I've had that like that. So anyways, what I'll do is I'll use this one. This one will give us a name rather than the CH300. So yes, so basically we'll get rid of the Arduino. Oh, let's just focus in. Don't need them pins in there anymore. That's the Arduino out. We've got the board. We're connected up as UART still. We've got the power still. I'll just turn that off for a moment because I like to check my connections first. I'm blind as a bat and I sometimes get them wrong way around. So before I add any power, I like to check things. Are these leads going to be alright? Where's my glasses? There we go. No, they're not. I need the other leads. I'm going to use these leads because these are all separated out, these. Right, so let's connect that up again. So we've got those on there. That on there. And that on ground. Oh, it's gone off again. I've lost my Wi-Fi. Let's try again. Must have a timeout on that, I don't know. There we go. There we go. I don't have a proper camera or anything, so stick with that. Let's make it a bit bigger. See what we're doing. Zoom in a bit. Yeah, it should do. Oh, there we go. Nope, got it wrong. There we go. Right, let's see how we go. Right, zoom in. So connect these ones up. And we've got that out wrong ones. Yeah, that's why I turned the power off. VCC and ground. There we go. Yep, so basically we've got the RX and TX, VCC and ground on there. We've got VCC, RX and TX and ground on there. So obviously the TX on here goes to RX on there, and the RX on here goes to TX on there. So it's opposite to opposite on the wires. We've got power, we've got servo, and I just need to plug that into a USB. So I've turned the power on, got my USB, let's plug that in. There we go. So got our server again, we've got the module, and we've got the USB to UART. And bring my application up. Now this time we don't want to use handshaking, because we're using a physical device here. This is hardware, this. So there's no software that wants to talk to each other. We just send what we send, and that's it basically. So I didn't DC last time, so because we're talking on the UART still, we still need to be at 9600, and I think it's COM7 is this one, and let's connect. And hopefully we move this, we move our servo, and there we go. Move that up and down. It runs a lot smoother when we're not going through an Arduino. But then again, the Arduino has to receive then send, whereas this we just send basically. So that's our UART, and just to show how well the UART works, what I've done, let's just disconnect that one also, so we don't need this anymore. Let's turn the power off for a moment. And what I've done is I have got my Bluetooth with my adapter, because hopefully you all know that the Bluetooth TX and RX pins on these modules are only 3.3 volts, so you need a logic voltage converter to convert those two pins from 3 volts to 5 volts. If you want to know more about Bluetooth, I've done a instructable. Here we are, how to use and configure. I've done the 4-pin and the 6-pin basic modules. It tells you all about it, and how to wire them up, how to change the name, the speed and everything. And you can see there that that's my logic converter. There we go. That's what that is. That's what this is here. So, well, this is my second one. That's another one I've used. So basically you have a voltage changer for it, and it tells you how to connect and everything. So you can use that. So like I say, the logic converter needs 5 and 3.3 volts. I need 3.3 volts to power the 3.3 volt side of this thing, but it does have a linear regulator for the 5 volt to give it power to 3.3 volts. So I'll be supplying power through 5 volts. We don't need this. I need that wire. We don't need the servo. I need the power. So let's just put some power to this board. That's for the servos. Now, because I'm powering the servos with 5 volts. Oh, I'll just bring a picture of this up so I can point out where I've wired this green cable to. Here we go. Right, yeah. These modules have a linear regulator. Basically, when you're powering these boards for the on the V plus side for the servo, this V plus and ground is this red and black line of pins here. They're all the same, so you can either connect here, or you can connect here on this any one of these red pins, or you can connect on this V plus here, this pin here. So all them pins, all the ones with the V plus on, like here V plus, which is this row of pins, they're all connected to the same. So you can see what I've done here. I've brought in the power and I've stuck it onto them two of these pins, sort of thing, down here, sort of thing. And that's the same as connecting to these two terminals. Makes no difference. Personally, I would have just put an extra header on rather than this terminal block, but there you go. Where was it? Oh, right, yes, so stick to this. So we have a linear regulator here, and this is, on mine it's 3.3 volts. You need to check, because I'm feeling that some of the circuits I've seen, I've shown it as a 5 volt, which is a bit pointless really if we're using 5 volts. Because you always get a voltage drop through a regulator unless you're going to a voltage lower than the voltage drop of the input. You're going to get a voltage drop. And this goes through this, there's a protection diode here, so that the voltage can only go one way through here. And so if you want to power something by 3.3 volts on here, it'll come through that diode. But like I say, with the, let's just look at my application. I've put some notes. So if we've got info here, I've put some notes. And we'll look at our servo. The pulse width modulation really wants to be a 5 volt signal. It wants to be 5 volts to get a good decent signal, and the servos will work a lot better, be more stable. What we want to do is we want to put 5 volts into the microcontroller. The voltage you put in is the same voltage you put out, comes out on the pins basically. And if we look at this chip, I put my notes, you can see that this microcontroller can run from 1.9 volts to 5 volts. So sticking 5 volts in on this pin is okay, and that's what powers the microcontroller. That powers the microcontroller, and if we power it with 5 volts, we're going to get a 5 volts pulse width modulation coming out of these pins. Now you don't have to worry about this linear regulator because of the protection diode. We're putting 5 volts in, it won't go through this, it won't go the wrong way through this protection diode. It protects the voltage regulator. So the voltage won't go through that way. 3.3 will come this way, but we're sticking 5 volts in this way, so basically we're getting 5 volts in. But I do want 3.3 volts for my my Bluetooth. So this bit here, this bit where it says D1 on that solder joint there, that is where I've wired my green wire, and that gives me 3 volts from this voltage regulator. There's 3 volts on this end. There's 5 volts on this end, but there's 3 on that end because the 5 volts can't go through that protection diode, so we still get our 3 volts here at D1 on that solder joint. So that was a lot easier to show. So that's where my green wire is. See if I can just get a bit closer to zoom in a bit. There, you can see I've just soldered it on to the end of there. And this is my 5 volts coming in, so we've got a 5 volt rail there, and what I've done is I've tapped into that. Let's focus. I've tapped into that 5 volts and I've put that 5 volts in on the VCC pin here. So we've got 5 volts going in there. Then I need another 5 volts. Well, what I'll do is we're connecting to the UART again, so just get my glasses on. And so basically we have our TX and RX pins on here, and we have our ground pin on here, and then our 5 volt, I just tapped that off this 5 volt rail here, so basically I've tapped it off here because this is being tapped off as well, because we've got no voltage coming in from our not that one. What have we got this for? We've got nothing coming in from our Bluetooth. We're only going that way with power. So now we've got our 4 wires. Just lining them all up. All separate. So now I'm adapter. Can I just get that in shot? I've got my 3 volts at the end, I've got my ground, I've got my 5 volts, and I've got my transmit and receive. So that's all going through my adapter to my Bluetooth. And get our servo, and I'll put my servo on number 0. First one. I'll just do a check that I've got the wires the right way. Yep, that looks fine. So now we have our servo. We have our servo, we have our module, and we have a Bluetooth module. So let's bring up my application again. Yes, so this time what I am going to do is go to COM6. That is the output to my Bluetooth from my PC to my Bluetooth on my PC, which then connects, which is paired with this Bluetooth device. And we're still on UART. Yeah, we're still on UART, but we're not going to use handshaking because we're actually using a physical hardware connection. We're not going through any software, so there's no handshaking to do because there's no software involved. We're just sending commands straight to the device through Bluetooth. So let's try connect. Oh, it'd be best if I hang about cancel that. Best if I turn the power on. Oh, hang about, I'll just let me just check again. Right, I've got power there on power. That's the right way. Oh, I've got them the wrong way around. Right. Try it that way. Yes, so we've got RX to TX and TX to RX. There we go. So hopefully that should work now. And I've got .35 ground. TX, which is orange, goes to RX. Yep, there we go. Let's try that again. This time I'll put the power on. Have I disconnected that? Why don't I see any power? Let me just check I've got some voltage. Everything was going smoothly up until now. And it's been a long video and I don't want to do it again. So let's just check I've got some voltage. Yep, 5 volts there. Have I got 3 volts there? .3 volts there. And I should have 5 volts there. Yep, 5 volts. So why isn't that flashing on and off? So VCC on the end. Oh, got them wrong way around. Hey. I got them the wrong way. Oh, that's why. Yeah, blind as a bat. Get that the right way around. And we're flashing now. So turn my meter off. And yes, let's try connecting this time. Oh, there we go, connected okay. Oh, you can't see me servo. So basically, we've got the servo module, and we've got the Bluetooth module, and we've got it connected right this time. I tell you, I can't see nothing. And a servo, so let's try this. Seems to be all okie dokie. Well, I hope you found that of some interest. I hope some things helped you with some things. Oh, yes, the commands. Right, I nearly forgot, didn't I? Right. Yeah, there are two types of commands. I think it's best using the info here. So I've put some information here. So basically, for the serial connection, the serial actually is a header byte and a footer byte. The address is set to 0, like I said before. When you're using UART, it's a one-to-one thing. You can only talk to one thing at a time and listen to one thing at a time. So they've made that 0, so the address is 0. And then you send the data. Well, like I say, what we'll be sending is this one here. They've changed the position of the server. There's no reply. You can check your connection by sending a query, and I've done that here. So basically, query. Oh, hang on, close that. Query. Oh, and you get that basically. You get these two numbers. That's all. That's the only hint that you've connected correctly is by getting them two numbers, really, by sending a query. This is a soft reset. If we look at the info again, you can see there's a soft reset. That button there that does is send this command. So it sends the header, the serial address, and then it sends them two numbers, and then it sends the footer. Basically, everything's done like that. So if we want to be able to see what it's sending there, what I can actually do is I can get rid of that. So depending on which one you've clicked on, you can see it's highlighting, and the highlighted one is when you add a single value, it'll add the value of the single thing there. So if I go add value that to the script, you can see there that what I'm going to send is that. So let's just it's got the header, it's got the address, it's got the servo number, it's got the servo position, and it's got the footer. And basically that's all you're sending to this. All you're sending is them 5 numbers. That's when you're in UART command. I'll just come out of there. I'll just DC from there because the I2C commands are different. So let's just clear that. Oh, connect. I need to connect to something. Right, so let's clear that. When you're in I2C mode, when you're sending stuff to the Arduino, and you have this selected, of course, for handshaking and everything, I'll just clear that. The commands you send are just 2 numbers. So if we select this as our active slider, and we add a single command, you can see that's the address we're sending to. So that's the I2C address. So it knows which module to send, and you can change the addresses of these modules using these solder jumpers down at the bottom. Just solder these across, and they act like a binary code to change the number of your address. And it starts at 128, so that's the address. That's the servo number, so this one. If I had this one selected, then and I did a single apply, you can see that the servo number would be number 1. And then the position, that's all you're actually sending to this when you're doing the I2C is the address, the one that you want to send it to, the servo number that you want to change, and the value. And that's it. You just send them numbers. There's no commas in there. I've just put commas in there to make it look okay, but you just send them values one after the other. And then that will actually change what's on that thing. So what I'll do is I'll just put it back to UART and connect. just so we can see what's doing, because I've got this set up as a UART at the moment. So let's just clear everything. Right, so this is our servo moving. So what I can do is I can say move it to there. Well, yeah, I'll move it to there, and I'll add a single value, which is this is to my script. And as I say, UART needs these headers on, whereas the others didn't. The other I2C just uses the 3 middle numbers here, whereas UART needs a header and a footer on top of everything else. So if I move that servo to there, and then I add that value again, add a single value. So that's my script. I run that script, and there you go, it moves backwards and forwards. Run it again, and then if I put the loop on and I run it, it'll run forever. And then just check loop off and it'll stop. So let's just do that again, clear that. So this time what I'll do is I'll put it right to there and add a single value. Then I'll put it right to here, add a single value. Then I'll put it back to 90, add a single value. Then I'll come back to here, add a value, and then I'll go back to there. Yeah, add a value. And then that's where it started, I think. Right, so I'll go back to center and add a value. A single value. There we go. So that's my script. That's what I want to send to it, and so I'll just run that script. There we go, and put the loop on. And turn the loop off. Now there may be occasions where when you're writing your code and doing your own project with your own robot and things, you may want to set more than one servo at a time, which you can. So maybe I wanted to change this one here, change that one there. Imagine all these connected to different servos and things and what have you, and you've got that set. You can add all values, and you can actually send that command where you have your header, your address, and it has this extra command ID, which basically what this command ID here is doing is saying there's going to be 20 more values following. So that there is just an identifier to say that this is a 20 value send, and then you have your footer after all things. So you've got these represent each one of your servos. Whereas when you did a single command, you had the servo number and the value. When you send all the commands, you have an identifier to say all are coming, and then you just send every value of every servo. And you actually put 20 in here because the chip, let's bring the picture. This chip actually has 20 pins allocated, and the other 4 pins is this one, this one, this one, and this one. These 4 here. These 4 pins are not actually connected to anything, but I think it was originally written that they were going to connect to 4 more pins, but I think they are a little unstable. Well, I've tried this pin and it seems to work alright, and this one is sort of. This one tends to be a bit temperamental, and this one, well, it does what it likes. But anyways, I think it was originally, because there were 4 more pins available, I think it was originally designed for 20, and that's why you have actually 20 values here instead of just the 16 values. And that's why I've added these 4 grade values, because they're for those extra 4 pins that are not actually broken out. But if you've got a steady hand and good soldering skills, you might want to try playing with those 4 pins. Yeah, so they're the commands. So you can either send a single command or a full command. And again, the I2C as this, well, the UART thing you've got to remember, the UART address is 0, and the I2 address is whatever it is, 126 onwards, whatever you've set. The I2C commands don't have this header or footer, but when you're doing UART commands, you need the header and footer. This is just like, it's a bit like handshaking. It's so it knows when there's the UART knows when there's the start of a command and end of a command. Whereas on an I2C you don't need that. You send an address and then you send the data. So it's slightly different ways of communicating. Yes, right, so I think I've about got to the end of that, and it hasn't crashed again. And I do love the fact that you can just connect with UART and just go for it and do all your playing without the Arduino. But then once you've written your scripts, then you just convert your scripts into whatever you want. You can save the scripts and load them in later on once you've made some. But like I say, it makes it easier for when you're actually doing a project. Oh yes, there's one more thing as well, presets. I am going to finish this eventually. This is where you can say that you're doing like this command, and you can copy and paste it here as well. So what you can do is you can copy that, and then you can sort of go down and paste your commands, and you can, once you know what the codes are, you can actually just write what you want. And obviously these can actually be put into these, so you can you can get the current values here. So these values, all these values, you can get the current, it'll put it into memory. You can give that a name, say like move leg sideways or something, and then you can save it. You can save all the presets. So then what you can do is you can come and load a set of presets, and then you can either add it to the script here, or you can send it straight to your project. But this isn't done yet. It's still work in progress. I just wanted to get this first bit sorted and my instructable. Yes, that's what I was going to do. I was just going to run through my instructable. So yes, I'm doing an instructable. So I should have started with this. So basically there's me leg, and I've got now, like I say, I've got a laser cutter. You need a laser cutter, a 3D printer. I've done some animations of how it all works. I've highlighted the red bits like I did with the when I showed you my leg. There's the 3D printed parts. Those are the plastic bits that you need, and obviously these are all the laser cut parts. And what I'm showing here is yeah, if we take a look at my leg, let's just bring that up. There we go. There. So when we're putting it together, it's got these plastic pins in there, which are basically lollipop sticks. They were cheap on eBay, and so I bought them. But what I'd done is, so you see the outer pieces, the hole in the middle is, I've made it tight fit for this plastic thing, but the holes in between the two outer bits, there should be a slack, so everything will move okay. And then between every joint I've put a cardboard shim. So basically that's standard all the way around for all the joints. Let's just bring that back there. Yeah, there we go. yeah, so you've got a spacer, and then you've got your shims and your parts and what have you. So that applies for all the joints, and then I just run through how they all go back. All go to these parts as well. I tried making these out of wood, but I ended up making them plastic. What I've done is, you see where these pins go in there. They're sort of bent double back a bit. But when I put them on, if I can just, let's see if I can zoom in onto that. I don't know if you can see there where I've actually, what I did was I heated this bit of plastic up, and then I crushed it with some pliers to cool it and set the pin in place. It was easier than gluing, like, so that's what I did. Yeah, and basically this drawing shows pretty much where all the horns on the servo should be when they're set at 90 degrees. And I've put the centres between the points to where roughly each linkage should be as well. So hopefully that shows them. So putting them all together, this is the way I built it. I found it the easiest way to do it. And linkage. Yeah, this is a bit complicated, this one. You might want to glue them two bits together to make it easier, or even glue that bit to that bit. But that hole there should be a pretty stiff hole, and this one's a bit of stiff hole, so that they both move together in tandem. It should all move as one unit. That. Yeah, and that's I've numbered the servos like 1, 2, 3, 4. That goes in line with the order I've put them on the order I've put them on this thing here. There we go. Bit brighter. Yeah. So that's that. Oh yeah, and this plastic print, rather than use. I don't use any support, or shall I say, I don't put like a layer down. I just print straight onto my bed, my printer. So when I need support, I usually draw it in, and you see there's just a little bit linking it together. That should just snap off. And then these are the other extra plastic bits that I screwed on, and the final pin, putting it all together. Bring it in, and then I'll just run through what I've basically said with the connecting up the pieces. I haven't shown the Bluetooth one here, but I've done fritzings for all the different sort of UART connections. So that's the UART to a UART device. That's the UART using the Arduino. So it's using a soft serial here, there you can see there. And then this is the connection using I2C, so we're coming off A4 and 5 there. Yeah, the code. Well, I said the code there, so I've already said there for the code. I put some information for the module that I found, and put all the values. Yeah, there we go. So, well, it was a long one, and I tend to ramble a lot. So hopefully, well, I hope you found it useful, and if you've made it all the way to the end, congratulations. Go make yourself a cup of tea. I think you've really done well. Thank you for watching.